Hello, children. Today we begin with a new topic, inscribed angle theorem, which is a very important part of this lesson from the exam point of view and also application point of view, because you will find lot of questions based on this theorem. Okay. So to begin with, before we start with the theorem, there are few things which you need to know, which we are going to learn through this activity which is there in your textbook. So I hope all of you have your textbooks open to page number 64. Now the first activity, draw a sufficiently large circle of any radius as shown in the figure. Draw a chord AB and central angle ACB. Take any point D on the major arc and point E on the minor arc. Measure angle ADB and angle ACB and compare the measures. Measure angle ADB and angle AEB, add the measures. So here what we have done is you have drawn a circle of a suitable radius. You have drawn a chord AB. C is the center of the circle. You have joined AC and CB. So you get a central angle, angle ACB. Take different points on the major arc, H, D, F, G. Join ADB. Now take a point E on the minor arc, join AE and EB. Consider one more point I in the minor arc. Now these are the things which you have done in which is shown in the figure. Now what you will notice from the activity is, if you do this activity, you will find that measure of angle ACB is twice the measure of angle ADB. So the measure of the central angle you will find is twice the measure of the angle which is inscribed at any other point on the circle. Measure of angle ACB is twice the measure of angle ADB. Second, the sum of the measures of angle ADB and AEB is 180 degrees. So if you were to add angle ADB and angle AEB, you would get 180 degrees. Third, angles AHB, ADB, AFB and AGB are of equal measures. So if you were to join AH and HB, AF and FB, AG and GB, and you were to measure all these angles, you would find that all of them are of equal measure. So these are all angles which are in the same arc, intercepted by the same arc. Now, if I were to measure angle AEB, now these are angles in the minor arc, angle AEB and angle AIB, I would get the measures to be equal. So these are the points that you will notice after doing this activity. Now there's another activity given too, wherein you are drawing a circle, drawing the diameter PQ, and you have 2 points R and S on one side of the arc, and you join PR to RQ, PS to SQ, and if you were to note the measure of the angles, you would find that they are right angles. Okay, we are going to learn why it is so in the following activities or theorems. Next, you have what is inscribed angle. You're going to learn what is an inscribed angle. In the figure, C is the center of a circle. Vertex D of angle PDQ lies on the circle. The arms of angle PDQ intersect the circle at A and B. Such an angle is called an angle inscribed in the circle or in the arc. In figure 3.42, angle ADB is inscribed in the arc ADB. Okay. Now this is called as an inscribed angle because angle ADB is inscribed in the circle, and the angles of this inscribed angle touch the circle or intersect the circle at two other points. That is, here it is A and B. Now it is actually inscribed in the arc ADB. You will find that this angle ADB is inside the arc ADB and it is intercepted by the arc AB. Children, there is a difference between saying that an angle is inscribed in the arc and it is intercepted by the arc. Now, what is the difference between inscribed and intercepted? Now, if you look at this angle ADB, you find that it is actually present in the arc ADB. Now, the circle if you consider, it is divided into two arcs. Okay, there is a major arc ADB and there is a minor arc AB, which is this minor arc AB towards the downside AB. Okay, that is at the if you can call it the open part of the angle. The open part of the angle is the arc AB, and the other part of the angle in which the angle is present is a major arc ADB, and together ADB and the minor arc AB together constitutes the circle. Okay, so angle ADB is inscribed in the arc ADB, which is a major arc, and it is intercepted by the minor arc AB. Okay, so I hope you are able to differentiate between what is meant by inscribed and intercepted, because why I'm explaining this is you should understand what is inscribed and intercepted, because in the theorem that follows these terms are going to be there and you need to know what it means. Okay, so that's an inscribed angle. Here in this figure 3.43, you have intercepted arcs. See, if you look at all these figures, angle ABC in all these figures are inscribed angles. Now they are intercepted by the arcs AC. In the second figure, it is the outer portion of the arc BC. Okay, then the remaining circles have all the inscribed angles have been intercepted by the arcs AC. Now in figures 4, 5 and 6, of course, there are two different arcs which are intercepting it because the angles are outside. Okay, now I'll explain to you as we go ahead with the theorem. Now figure 3.44, you cannot call it an inscribed angle or an intercepted arc because BC, the other part of the angle, is not touching the circle and therefore it is not an intercepted arc. Okay, now we come to the most important part of the lesson, which is called inscribed angle theorem. It is very important to learn the theorem as well as to learn the proof of it and to understand it well so that you can use it to apply and do the sums in the exercise. So pay attention here, children, as I explain to you this theorem. At the end of it, I'll tell you what are the things that you need to write in your classwork. Okay. Inscribed angle theorem. The measure of an inscribed angle is half the measure of the arc intercepted by it. Okay, so the theorem says the measure of an inscribed angle is half of the measure of the arc intercepted by it. Now, which is the inscribed angle you find in the figure and which is the arc that is intercepted by the angle? Now, if you look at the figure, O is the center of the circle, angle BAC is the inscribed angle. Okay, and which is the arc which is intercepted by this angle BAC? It is the arc BDC which is intercepting the angle BAC. And where is it inscribed? Angle BAC is inscribed where? In the arc BAC. Okay, now I hope children you are able to understand the difference between inscribed and intercepted. Do not get confused. Angle BAC is inscribed in the arc BAC, means where is it present? It is present in the arc BAC. And which is the arc intercepting it? That is, look at the mouth of the angle, the open portion of the angle, which is the arc there, BDC. So that is the arc intercepting it. Okay. Now given in a circle with center O, angle BAC is inscribed in the arc BAC. Arc BDC is intercepted by the angle. Okay, I hope now you are able to understand clearly inscribed and intercepted. What must you prove? Angle BAC is half the measure of the arc BDC. This is what you have to prove. Construction. Draw ray AO. It intersects the circle at E. Draw the radius OC. This is the construction. Now for proof, take triangle AOC. Side OA is congruent to OC because they are the radii of the same circle. Angle OAC and angle OCA are equal because due to theorem of isosceles triangle. You have OA and OC equal because they are the radii. Therefore, the angles opposite to equal sides are equal. So we have considered let both of them be equal to x, and this is due to theorem of isosceles triangle. Now angle EOC is equal to angle OAC plus angle OCA. Reason? Exterior angle theorem. The exterior angle of a triangle is equal to sum of its two remote interior angles. Okay, so that's angle EOC will be equal to x plus x, which is 2x. But angle EOC is a central angle. Measure of the arc EX equal to 2x. Definition of measure of an arc. So an arc is always equal to the measure of its central angle. That is why measure of the arc EC equal to 2x, because the measure of the central angle is 2x degrees. Now from 1 and 2, what do you get? Angle OAC is equal to angle EAC. Yes, angle OAC equal to angle EAC, which is equal to half of measure of arc EC. Okay, so angle EAC and angle OAC are one and the same, because A dash O dash E, and it is equal to half of the measure of arc EC. Okay, so you find that angle EAC is x, and uh, the arc EC is 2x. So definitely measure of angle EAC is half of the measure of arc EC. Mark it as equation number 3. Now, if you were to do the same thing with OB, that is, if I were to draw segment OB, we can prove that angle EAB equal to half of the measure of arc BE. So mark it as equation number 4. Now, from 3 and 4, that is measure of angle EAC plus angle EAB, we are adding both the angles to the on the left hand side. It will be equal to what is there on the right hand side, half of measure of arc EC plus half of measure of arc BE. Now what is angle EAC plus angle EAB? It is angle BAC. So on the left hand side, right angle BAC, and half is common on the right hand side for both. Take it common, and measure of arc EC plus measure of arc BE. What is measure of arc EC plus measure of arc BE? It is measure of arc BEC or measure of arc BDC. So what have we finally got? Angle BAC is equal to half of measure of the arc BDC. So we have proved that the measure of an inscribed angle is equal to half of the measure of the arc which is intercepting it, okay, which is the theorem. Now that, note that we have to consider 3 cases regarding the position of the center of the circle and the inscribed angle. The center of the circle lies on one of the arms of the angle, second in the interior of the angle, and third in the exterior of the angle. Out of these, first 2 are proved in 3 and 5. That is, we have proved, suppose if the measure of the central angle lies on one of the arms, or if it is in the center of the circle, we have proved both these cases with this particular part of the theorem. But suppose if the point lies in the exterior of the angle, as in figure 3.46. See, look at the figure here. You have angle BAC and you have another point E which lies in the exterior. How will I prove it? Angle BAC equal to angle BAE minus angle CAE. Correct? BAC equal to angle BAE minus angle CAE. Now, if I were to write in terms of measure of the arcs, I would write half measure of arc BCE. Okay, that is for BAE, I can write it as it is intercepted by the arc BCE. So half measure arc BCE minus half measure of the arc CAE, I'll write it as CE. Okay, now half is common, take it outside. Measure of arc BCE minus measure of arc CE is nothing but measure of arc BC. So what do I get? Angle BAC equal to half of measure of the arc BC. So the inscribed angle is equal to half of the measure of the arc subtending it, right? So I have proved all the 3 cases. So the above theorem can also be stated as follows. The measure of an angle subtended by an arc at any point on the circle is half of the measure of the arc, half of the measure of the angle subtended by the arc at the center. Why? Because the measure of the angle at the center is equal to the measure of the arc subtending it. Okay, so it can be stated like this also. So I hope children, the inscribed angle theorem is clear to you. Go through it once again, understand each line of it clearly, because every line of it is important for you. Only then you will be able to understand how to prove it. And the first part of it is to prove the interior as well as on the side. The second part of it proves if it lies in the exterior. So if you are asked to state and prove inscribed angle theorem, you need to write up till here the complete theorem. Okay, so that's about the inscribed angle theorem. Now there are certain corollaries, that is what you infer from this theorem, that is meant by a corollary. The first one, angles inscribed in the same arc are congruent. What it means is, if you have more than an arc which is subtended by the same arc, all those angles will be congruent. For example, you have an angle, you have a circle here, figure 3.47. Center is C. You have an angle PQR which is subtended by the arc PTR, or intercepted. Intercepted and subtended is the same. Okay, angle PQR is intercepted by the arc PTR. Angle PSR is subtended or intercepted by the arc PTR. Now both angles are congruent. Angle PQR is congruent to angle PSR. Can you tell me the reason why? Angle PQR is equal to half of measure of the arc PTR by inscribed angle theorem. Similarly, angle PSR is half of the measure of the arc PTR by inscribed angle theorem. So the right hand sides for both are equal. Therefore, the left hand sides are equal, and hence angle PQR equal to angle PSR. So angles inscribed in the same arc are congruent. Okay, this is how the proof has to be written. Though they have not asked you for the proof, you can understand it. I have explained to you how to write it. Now the second corollary, angle inscribed in a semicircle is a right angle. So if you have AMC to be the diameter, angle ABC will be a right angle. Now how is it a right angle? If I consider angle ABC, it is half of measure of the arc AXC. What is AXC? It is a semicircle. So 180. So half of 180 is 90. So angle ABC is equal to 90 degrees. So measure of an angle inscribed in a semicircle is always a right angle. So these are the two corollaries. Okay. Next we go to the another important part of this lesson, which is a cyclic quadrilateral. What it means is, if all vertices of a quadrilateral lie on the same circle, then it is called as a cyclic quadrilateral. Okay, so if you have a quadrilateral and all the vertices of it lie on the same circle, it's called as a cyclic quadrilateral. There is a theorem that we learn: opposite angles of a cyclic quadrilateral are supplementary. It's a very, very easy theorem and a very important one. It is usually asked in the question papers. If you look at your old question papers, you will find that most of your papers will have this question. It's a very simple theorem. Usually it's asked for 3 marks. Okay. Now the theorem says opposite angles of a cyclic quadrilateral are supplementary. Now it's an activity based question. It is given to you this way. Not necessary that it should be given like this even for your exam. So you need to learn what is given to prove and prove properly. So I'm going to explain it to you. As I explain, you can write it in your textbook with pencil for now, and then write it later in your classwork. After I finish explaining, I'll tell you what are the things to be written in your classwork, and you can do it. Okay. Now, as I explain to you now, you can make a note of it with your pencil in your textbook. Fill in the blanks and complete the following proof. Given quadrilateral dash is cyclic. What will you write? Quadrilateral ABCD is cyclic. To prove angle B plus angle D is equal to 180 degrees, the next box you will write angle A. Angle A plus angle C is 180 degrees. Okay. So I'll explain once again. Given quadrilateral ABCD is cyclic. To prove angle B plus angle D is 180 degrees. Angle A plus angle C is 180 degrees. Coming to the proof. Arc ABC is intercepted by the inscribed angle ADC. Okay. angle ADC is equal to half of measure of the arc ABC. So what are you going to write in that box there? Half measure of arc ABC. Measure of the arc ABC. Okay, that's equation 1. Similarly, again there's a box, is an inscribed angle. What will you write? Similarly, angle ABC is an inscribed angle. Similarly, angle ABC is an inscribed angle. It intercepts the arc ADC. Therefore, the third box, what will you write? Angle ABC is equal to half measure of the arc ADC. So, angle ABC equal to half measure of the arc ADC. Next step, measure of angle ADC plus measure of angle ABC. Okay, measure of angle ADC plus measure of angle ABC equal to half measure of the arc ABC plus half measure of the arc ADC. So what is that box there? Half measure of the arc ABC plus half measure of the arc ADC from 1 and 2, which is equal to half is taken outside in the bracket, measure of arc ABC plus measure of arc ADC. So that box should have measure of arc ABC. Now that is equal to half into 360 because ABC and ADC together constitute a complete circle. So half into 360. The next box equal to 180 degrees. Similarly, we can prove angle A plus angle C equal to 180 degrees. Okay. So this is how you have to write complete the boxes and fill up. I'll explain to you this theorem. Look at the figure and try to understand what you have just written. You are given quadrilateral ABCD is cyclic. You have to prove angle B plus angle D is 180, angle A plus angle C is 180 degrees. What is the proof? Arc ABC is intercepted by the angle ADC. So what is angle ADC equal to? Half measure of the arc ABC. Similarly, angle ABC is an inscribed angle. It intercepts the arc ADC. So you have angle ABC equal to half of the measure of arc ADC. Now angle ADC plus angle ABC equal to half measure of the arc ABC plus half measure of the arc ADC. Take half outside, add measure of arc ABC plus ADC. ABC and ADC together constitute a circle, therefore 360. Therefore your answer is 180. So you have angle B plus angle D is 180. Similarly, you can prove angle A plus angle C is 180. Children, I hope the theorem is clear. I've explained to you once again because it's important, very important from your exam point of view. So please write it properly and then you need to write it in your classwork and learn it properly. Okay. The next is a corollary of the cyclic quadrilateral theorem. An exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. Now I want you all to draw the figure for it and try to write the proof. Okay, what does it say? You should draw first a cyclic quadrilateral, extend it to one side, one part of it, so that will be your exterior angle. That is congruent to the angle opposite to its adjacent interior angle. The angle next to it and the angle opposite to it. So that should be equal to the exterior angle. If you're able to understand, please draw the figure and try to write the proof. If not, I will explain to you in the next session when we begin with the exercise how to do this. Okay. So that's your corollary. Try to write the proof. In case you are unable to do it, I'll explain to you in the next session. Okay. Now what is converse of cyclic quadrilateral theorem? If a pair of opposite angles of a quadrilateral is supplementary, then the quadrilateral is cyclic. So the theorem converse says if you have a pair of opposite angles of a quadrilateral supplementary, then the quadrilateral is cyclic. Okay, so that's the converse. We come to our next theorem. If 2 points on a given line subtend equal angles at 2 distinct points which lie on the same side of the line, then the 4 points are concyclic. What it means is if you have 2 points on a given line, okay, and so we are considering the line which is AD. You have 2 points on the same side of the line which are B and C, and if you find that these two angles which are subtended are congruent, that is angle ABD and angle ACD are congruent, then all 4 points A, B, C, D are concyclic. This is what the theorem says. If 2 points on a given line subtend equal angles at 2 distinct points, so it is angle ABC and angle ACD, these are the 2 angles which are being subtended on the same side of line AD, then all 4 points A, B, C, D are concyclic. You need to understand this theorem because application of this theorem is there in your exercise. Okay, so that's about the theorem. With this, we finish with the theoretical part of the exercise to begin with the before we begin. Now in this, remember this, these are all what we have done just now, excepting for points number 9 and 10. Now figure 3.54, if you look at it, angle AEC, how do I find out? Half measure of the arc AC plus measure of the arc DB. Angle CEB equal to half measure of the arc AD plus measure of the arc CB. Okay. Question point number 10, angle BED equal to half measure of the arc BD minus measure of the arc AC. Now these are 2 more cases of inscribed angle theorem which were not mentioned in your in the first part of your book, but both 9 and 10 are important because questions based on this have been asked in your exercise. Now I'll explain to you what are the things that you need to write in your classwork. Okay. Now to begin with, you will first write this inscribed angle. These activities were just for you to understand the theorems that you're going to write. So you don't have to write this. What you will write in your classwork is first this inscribed angle. You will write the heading inscribed angle. You will draw figure 3.42 and write C is the center of the circle. Vertex D of angle PDQ lies on the circle. Arms of angle PDQ intersect circles at A and B. Such an angle is called an angle inscribed in the circle or in the arc. In the figure, angle ADB is inscribed in the arc ADB. Okay, and it is intercepted by the arc AB. So that's it about the inscribed angle. This you need not do it. We straight come to inscribed angle theorem. Now this, the statement of the theorem with the complete theorem has to be written by you up to this point. The last statement, measure of the angle subtended by the arc at the center. So what is written in bold, black letters, you have to write till there. Okay. After that, you come to corollary of inscribed angle theorem. You just need to draw the figure and write the corollary. Angles inscribed in the same arc are congruent. Draw the figure. Angles inscribed in a semicircle is a right angle. Draw the figure 3.48. Okay. These are the 2 corollaries to be written. Come to cyclic quadrilateral, write the definition of a cyclic quadrilateral. Theorem of cyclic quadrilateral, as I explained, complete thing you will write. Corollary of cyclic quadrilateral theorem, you will write an exterior angle of a cyclic quadrilateral congruent to angle opposite to adjacent interior angle. If you are able to write the proof on your own, well and good, please do it. In case you are not able to do it, leave some place for it. I'll explain to you how to do it when I explain the exercise to you, and that time you can write it down in case you haven't written. The ones who have written, you can check whether what you have written is correct. Okay. Next, you go to converse. You need to write only the statement. Okay. If a pair of opposite angles are supplementary, quadrilateral is cyclic. Next, you go to this theorem. You need to write the statement of that theorem and draw the figure 3.5. That's all. No need to write the given and to prove. You need to write the theorem, draw the figure. Okay. Now you go to this particular point. Remember this. And here, need not write need not write the points 1 to 8. Okay. All this you have already written. You have to write only 9 and 10. Draw figure 3.54. Write both those points. Draw figure 3.55. Write the point number 10. So these are the things to be written. Okay. So you will complete till here and be ready to begin with exercise 3.4 in my next video. So complete till here, children, and be prepared. So that's it. Thank you.